Hello and welcome to the Victor tutorial on how to use the Tephra2 workflow. Tephra2 is used to simulate tephra fallout deposits associated with explosive volcanic eruptions. Tephra2 produces estimates of mass loading or grain size distribution at map locations based on specified eruption source parameters, shortened as ESPs in this specific workflow, as well as wind datasets. In this solution, ESPs are specified, a wind field is specified, and the map locations where tephra accumulation is calculated are also specified. So this workflow is especially useful for a few things, including simulating an explosive eruption and generating an isomass map with Tephra2, learning about ESPs and their impact on tephra accumulation, creating input files for Tephra2, executing compiled codes from the notebook, and manipulating model output with pandas and making simple contour plots. We have a few steps here as part of this workflow. In order, we have build a configuration file for Tephra2 consisting of eruption source parameters and saving this file. Building a grid file for Tephra2 consisting of the points where tephra accumulation will be modeled and saving this file. Building a wind file for Tephra2 consisting of wind velocity as a function of height and saving this file. Running Tephra2, parsing the Tephra2 output to obtain isomass information, and then lastly, plotting an isomass map from the parsed Tephra2 output. So we can get right to it by running the initial, importing the initial required libraries, and we hit this cell, which in which Tephra2 requires a wind velocity to be specified as a function of height above the ground surface. We can of course change these values to change the wind direction as a function of height in the simulation, with any number of wind heights able to be specified by adding more pressure values. We can also, in this case, we can also specify dates, coordinates, and pressure values in order to generate the wind field. So I'll use the example values that we already have inputted here to keep running this. Once we run all of those, we'll hit this cell, which allows us to create the Tephra2 configuration file. The configuration file contains all the ESP's information, which is of course required to run the model. We don't recommend or don't change any of these keywords, just because it'll cause the code later on to not run properly. Included already are easting and northing coordinates of the vent, as well as vent elevation, plume height, the eruption mass, the median grain size, and the standard grain size, which it specifies over here what each of these keywords mean and what units they're all in. We can keep running as normal. Once we get here, there are also a few additional parameters which you can add it as you wish. All the descriptions for these parameters are listed here, as well as again what units they're in. There are 11 different parameters that you can control, so definitely refer to this text here if you wish to use those properly and incorporate them into your model. For now, I'll keep using the example parameters. This cell over here controls our grid file and creates it. The grid file is a list of locations and elevations where tephra accumulation will be calculated. Do note that Tephra2 must have the elevation equal on all of the points. You can alter the code in this cell to make your own grid, but again, in this case, I'll be using the defaults that are pre-inputted into the notebook. Once we do that, we can run Tephra2 using this script down here, which uses our created configuration file, grid file, and win file in order to run. This might take a bit, so we'll return when it's done. All right, it finished running, so we can keep going and moving through. This cell over here manipulates the Tephra2 output. It reads the output file and it puts it into a pandas data frame, which contains a lot of information. You can then pull from the information, which is all stored in lists, which makes it a lot easier to plot. In this case, we'll extract the easting, northing, and mass data, put them into lists, which will allow us to more easily plot them below. But I'll run this line of code. And then once we're there, this script over here shows you one way at least to plot the Tephra2 isomass data, which we can then run, and we can get this nice plot as a result. So this is of course just one of the many ways that you can use and customize the Tephra2 workflow. If you need any additional information, please refer to our documentation at victor.readthedocs.io.